Today's video is an introduction to Le Chatelier's principle. When a system that is in equilibrium is disturbed, the system will always appear to react in the direction that opposes the change until a new equilibrium is reached. The system tries to do the opposite of the change that is imposed. Le Chatelier's principle involves a three-stage process. There is the equilibrium state, the shifting non-equilibrium state, and a new equilibrium state. Le Chatelier's principle allows us to predict the response of a chemical system to an imposed change. If some of a reactant is added to a system, the equilibrium is expected to shift forward or to the right. This is because the system will behave in such a way as to do the opposite of the change imposed. When additional reactant is added, the system will move in the forward direction so that it can remove some of the additional reactant. Ultimately, the system will establish a new state of equilibrium. In this example, the reaction of carbon tetrachloride with hydrogen fluoride is used to create freon, which is a refrigerant. The system is in equilibrium. If somebody wants to improve the yield of freon, additional hydrogen fluoride can be added to shift the equilibrium to the right. When the system reaches equilibrium, the concentration of the reactants and products will not be the same as before equilibrium was disrupted. If additional carbon tetrafluoride is added, the equilibrium is not shifted forward in the same way as when hydrogen fluoride is added. This is because carbon tetrachloride is in liquid form, so its concentration is constant. When extra is added, its concentration is not changed, so equilibrium is not affected. According to Le Chatelier's principle, when product is removed, equilibrium will shift to the right. This is a result of the system making an effort to recover the loss of product. In doing so, more of the reactant is to be used up. If we want to move equilibrium to the right, either of the gaseous products could be removed. Le Chatelier's principle can be used to explain some biological phenomena. For example, the transfer of oxygen to hemoglobin in our capillaries is due to oxygen being removed and a shift of equilibrium to the left so that more oxygen is released. Please complete the December 4th quiz.